Have you ever gazed into the night sky and asked yourself the oldest question in human history? Are we truly alone? Billions of stars burn across the universe. Trillions of planets orbit in endless cosmic dances. And yet here we stand, on a small blue world, wondering if life exists beyond our fragile bubble. For centuries, the question lived in mythology, religion, and science fiction. But today, science is no longer asking if life could exist elsewhere. Now we ask, where? Our telescopes can see worlds orbiting distant suns. Our spacecraft can dive into oceans hidden beneath ice. And our rovers can taste the soil of alien deserts. The possibilities are breathtaking. From frozen moons that may hide entire oceans, to exoplanets that mirror Earth across light years, to strange, exotic worlds where life might not look like anything we've ever imagined. This is not fantasy. This is a journey grounded in science. And tonight, we will travel together, exploring the top candidates for life beyond Earth. Get ready, because the search for alien life isn't about them. It's about us, about discovering whether life is a rare miracle or a universal rule written into the fabric of the cosmos. Mars, the Red Wanderer, a planet that has haunted human imagination for centuries. When early astronomers saw canals etched into its surface, they dreamed of civilizations, of ancient cities and dying worlds. While those ideas were illusions, the truth about Mars may be just as fascinating. Billions of years ago, Mars was alive in ways we can scarcely imagine. It was a planet of flowing rivers, sprawling lakes, and possibly a vast northern ocean. Evidence lies in its dried riverbeds, deltas, and minerals that only form in liquid water. Water is life's stage. Where it flows, life follows. So the question echoes. Did Mars once host biology? NASA's rovers, Spirit, Opportunity, Curiosity, and now Perseverance, have all uncovered signs of a wetter past. Perseverance, in particular, is exploring an ancient river delta in Geyser crater, once a fertile environment where microbial life could have thrived. And what about today? Mars is cold, dry, and battered by radiation. But scientists believe pockets of briny liquid water may still exist beneath its dusty surface. If microbes survived underground, clinging to chemical energy, Mars might still be alive. Future missions hold the key. The Mars Sample Return Project aims to bring Martian soil back to Earth, where the most advanced laboratories can search for biosignatures, organic molecules, isotopes, or even fossilized microbes. Mars is also our most likely candidate for human exploration. If we find life there, it will answer a profound question. Is Earth unique, or is biology a natural consequence of planets with water? And if life once thrived on both Earth and Mars, even within one solar system, then the universe must be teeming with it. Let us leave Mars behind and journey outward to the realm of giants. Jupiter, the largest planet in our solar system, guards dozens of moons. But one moon, Europa, may be more promising than all the rest. At first glance, Europa looks dead. Its surface is cracked, frozen, and scarred with long, dark lines. But that icy crust hides a secret. Beneath it lies a global ocean, containing twice as much water as all the oceans of Earth combined. This is stunning. Liquid water, shielded from radiation, warmed by tidal heating as Jupiter's immense gravity stretches Europa's core. On Earth, deep-sea hydrothermal vents teem with creatures, giant tube worms, bacteria, entire ecosystems thriving in total darkness. If it happens here, why not there? Europa's surface even shows hints of water plumes, geysers shooting through cracks into space. If confirmed, these plumes would offer us a chance to taste Europa's hidden ocean, without drilling a single hole. NASA's Europa Clipper, launching soon, will orbit Jupiter and fly past Europa dozens of times. It will scan the ice, sample the thin atmosphere, and search for the chemistry of life. Europa is one of the most tantalizing places in the solar system. Its ocean is vast, ancient, and stable. If microbial life arose there, it could still thrive today, feeding on chemical energy near hydrothermal vents. And if we find life in Europa's ocean, the implications are staggering. It would mean life is not only possible, but likely to arise wherever conditions allow. A second genesis of biology, right next door. Europa whispers a promise. The universe may be far more alive than we ever dreamed. Farther still, orbiting Saturn lies a tiny, icy moon, Enceladus, barely 500 kilometers wide, yet home to a breathtaking discovery. In 2005, the Cassini spacecraft spotted jets of water vapor erupting from Enceladus's south pole, geysers blasting into space like cosmic fountains. Those plumes revealed something extraordinary, a subsurface ocean beneath the ice. Cassini flew directly through them, sampling their contents. The results stunned scientists. Inside those icy sprays were organic molecules, salts, even hints of hydrothermal activity at the ocean floor. The exact recipe that, on Earth, supports entire ecosystems. What makes Enceladus special is accessibility. Unlike Europa, we don't need to dig through kilometers of ice. Its ocean is already venting into space, free to study. A future probe could fly through those geysers again, armed with instruments capable of detecting actual microbes. It's almost as if Enceladus is offering us a sample of its ocean, begging us to look closer. This tiny moon reminds us, size does not matter. Even the smallest worlds can carry the biggest secrets. Now we turn to Titan, Saturn's largest moon, a world that may hold answers and questions that rewrite the definition of life itself. Titan is shrouded in a thick orange atmosphere, the only moon with weather, clouds, and rain. But instead of water, it rains methane. Its rivers and lakes glisten not with H2O, but with liquid hydrocarbons. This is an alien chemistry unlike anywhere else in the solar system. Could life exist here, built on methane instead of water? On Earth, life depends on liquid water as a solvent. But some scientists propose Titan could host exotic life forms, organisms with cell membranes adapted to methane, thriving in cold beyond imagination. Titan's surface is a frozen desert of dunes and lakes, but below lies another mystery, a possible subsurface water ocean. That means Titan could host two different habitats, one for exotic life, one for water-based life. NASA's Dragonfly mission will explore Titan like never before. A nuclear-powered drone capable of flying across dunes, lakes, and icy plains. It will study Titan's chemistry, searching for complex molecules that hint at prebiotic or biological processes. Titan is more than a candidate for life. It's a candidate for different life, a reminder that biology might not follow a single rule book. If we find life there, it would prove that the universe writes life in many languages. Beyond our solar system, the real treasure awaits. Exoplanets, worlds orbiting distant stars. 30 years ago, we didn't know if other stars had planets. Now we've confirmed thousands. And among them, many orbit in the habitable zone, where liquid water could exist. Planets like Proxima Centauri b, orbiting the closest star to our solar system. Or the famous TRAPPIST-1 system, with 7 Earth-sized worlds, 3 of which may be habitable. Imagine, an entire family of planets, each with its own chance at life. We've also found super-Earths, larger, rocky planets that may hold thicker atmospheres and more stable climates than Earth itself. The James Webb Space Telescope is now studying the atmospheres of these exoplanets. It searches for biosignatures, gases like oxygen, methane, or chemical imbalances that hint at biological processes. The day we detect an alien atmosphere filled with oxygen and methane will be the day we know. Life exists elsewhere. Not in a far galaxy, but orbiting a nearby star. These planets are out of reach for now, but they remind us that Earth is not unique, that the Milky Way alone may host billions of habitable worlds, and if even a fraction are alive, the universe must be teeming with life. Exoplanets are not just candidates, they are the ultimate proof that the search has only just begun. The search doesn't stop with the obvious. Other worlds may hold hidden potential. Venus, long dismissed as a fiery hellscape, surprised scientists with hints of phosphine in its atmosphere. On Earth, phosphine is produced by microbes. The signal is debated, but it reminds us, never assume a world is dead. Ceres in the asteroid belt shows signs of salty brines below its crust. Pluto, at the edge of the solar system, may harbor a liquid ocean under its ice. Even moons we once ignored could hold possibilities. Everywhere we look, the universe offers hints, whispers, and promises. Life may not be rare, it may be inevitable. So, are we alone? Mars tells us life may have once thrived in our own neighborhood. Europa and Enceladus whisper of oceans that could be alive right now. Titan tempts us with alien chemistry. Exoplanets shine as Earth's distant cousins. Each world is a candidate. Each world carries a possibility. And together they form a chorus of hope. The truth is, life is resilient. On Earth, it thrives in boiling acid, in frozen glaciers, in the crushing depths of the ocean. If life can exist here, it can exist almost anywhere. The next decades may bring the answer. We may detect alien microbes. We may discover strange biospheres. Or we may glimpse an atmosphere on a distant exoplanet, filled with the breath of alien life. And when that day comes, it will change everything. Not just science, but philosophy, religion, and our sense of who we are. Because life beyond Earth would remind us that we are part of something vast.